Here's example 6 of solving trig equations. So here we have tangent of theta equals 2.49, and part A says solve in the interval 0 to pi. So if you've been watching the previous examples, we've always been doing 0 to 2 pi. Now we're going to do 0 to pi. Part B is the same, find the general solutions. So why are we doing 0 to pi instead? Well, first of all, this just means 0 is less than or equal to theta is strictly less than pi. Well, the reason is that now that we're doing a tangent function, the period of the tangent function is pi. So we only really have to look at 0 to pi, okay? Because after that, everything's just repeated by the periodicity of the tangent function. So we only want to look in 0 to pi, so we're just going to do that. Now, how do we do this? Well, we actually just approach it the same way that we've been doing. So let's draw a unit circle. And actually, tangent's a little bit simpler because we don't have to do, for this specific example anyway, we don't have to worry about symmetry properties or anything like that. Because since we're only looking in 0 to pi, we're actually only going to have one specific solution for part A. So if we draw our unit circle here, okay, so tangent of theta is 2.49. Where is tangent of theta positive? So in general, the tangent function is positive in quadrant 1 and quadrant 3. Okay, but quadrant 3 is actually outside of this interval. So 0 to pi just means, so here's angle 0, and then angle pi would be over here. Okay, so our answer is just going to be somewhere up here above the x-axis in quadrant 1 or quadrant 2. Okay? But since tangent of theta is a positive number, then we're somewhere in quadrant 1. Okay, so we'll just draw it over here, somewhere approximately. So here is our theta. Okay. Now, how do we get it? Well, we just straight up take the inverse tangent. That's pretty much it. So theta equals the inverse tangent of 2.49. Okay, and let's go ahead and pull out our calculator and see what that is. Okay, so make sure we're in radian mode unless otherwise specified, and then make sure we do the inverse trig function. So we want the inverse tangent of 2.49, and we see that's approximately 1.1889. So let's go ahead and write that down. So theta is approximately 1.1889. And that's pretty much it for part A. That's our answer for part A right there. Okay, now how do we answer part B? Find the general solutions. So now this is where things are a little bit different. So remember in the past, well, in the first 5 examples, we took our answer for part A and we just added the 2k pi. Well, we did 2k pi because we were dealing with sines and cosines, and sine and cosine have period 2 pi. Well, the tangent function only has period pi. So we just ignore the 2, or the 2's not even there. We're not ignoring it, it's not even there. So we're just going to add k pi. So what does that look like? Well, if we take this angle theta and add pi to it, so if we add pi to that, that's going to give us an angle down here. Okay, so then this whole thing is going to be theta plus pi. And then theta, so actually this angle right here and this angle down here, they have the same tangent, because remember the tangent function is period pi. So theta and theta plus pi both have the same tangent. And in this case, we know it's 2.49, that's what we were given. So, and that's pretty much it. So we just take so we say theta is approximately equal to 1.1889, and then plus k pi, where k is any integer. And this time I do have room to write the whole thing. Okay. So if k is 1, then that represents actually what we just drew here. Okay, so 1.1889 plus 1 times pi is going to put us here. If we add pi again, that's going to put us here. So if k were 2, okay, so k is 1, k is 2, k is 3, k is 4, k is 5, and so on and so forth. If k were a negative number, we would be going in the negative, the clockwise direction. So here's, if we start at theta, if k is negative 1, we go here, negative 2, negative 3, negative 4, and so on and so forth. Okay. So really that's pretty much it for this example. That's example 6 of solving trig equations.